Welcome to my video over volume of prisms and cylinders. To begin, we have volume is going to be the space that a three-dimensional figure is going to occupy. Since it is 3D, it is going to be measured in cubic units. Cavallari's principle states that if two 3D figures have the same height and they have the same cross-sectional area at every level, they're going to have the same volume. So in this first picture here, we have a base that is a rectangle that is 3 by 2 inches. And so the area of that base is going to be 6 inches squared. And in our second one, we have that the base is going to be a parallelogram with a height of 2 and a base of 3. So that 3 times 2 is going to give me 6, the same area I had with my rectangle. So since they have the same height, we should have the same volume in the end. Volume of a prism or cylinder is just going to be the product of the area of the base and the height of your 3D figure. So we have some examples that we're going to work through, and for all these examples, we're going to give exact answers only. So my preference when starting through with these problems is I'm going to start by just highlighting my bases. And so if you remember from my surface area video, we talk about that if you have a prism and all of your sides are rectangles, you can identify which rectangles you want to be your base. But if you have two sides that are not rectangles and they are congruent and parallel, such as these triangles here, those are going to serve as our bases. So with that being said, we're going to start off with our capital B, our area of the base. And so we have our triangles here. This is an isosceles triangle because we have one side of 20, another side of 20, and then our base could be that 24 feet. So in order to find the area of a triangle, we have that my formula is 1/2 base times height. And so I would need to know what is the height that is corresponding with this 24 feet base. And so I'm going to use Pythagorean theorem to solve for that. So we are going to use half of our base because it's going to bisect on an isosceles triangle, that altitude. So I'm going to use 12 squared plus b squared is going to be equal to 20 squared. When I square everything, I'm going to get 144 plus b squared is equal to 400. And when I subtract and take the square root, I should get 256. So the square root of that is going to be 16. So plugging in, we'll have our 1/2, our base, which is the 24, times my height of 16. So with that being said, I'm going to take half of 16 to get 8, and then 8 times that 24 is going to give me 192. Okay, and then the last thing to do is to find our h, our height of the prism. And so we are going to look from base to base. So from one triangle to the other, we're going to look and see how far apart it is, which if I keep going around, I'm going to see this 32 feet. And so that's going to be my h. Now I have everything I need, so I'm going to just plug in for my volume. And we're going to take our area of the base, that 192, times 32. And when you multiply those two together, you should get 6,144. And we're going to have units cubed. All right, now let's move into number 2. So in number 2 here, we once again are still dealing with a prism, but this is going to have that circular base, so it's going to be a cylinder. And so I'm just highlighting my bases. Like I said, I always start by doing that. Helps me identify all the key things I need for the area of the base, as well as my H between the two bases. So we're going to start with our capital B, which is, since it's a circle, pi r squared. I do need to figure out that my radius is going to be half of that 8, because that is a diameter. So it's going to be 4. So I'll have that 4 squared times pi, which is just going to give me 16 pi. Remember, we're going to leave our answers exact. Therefore, I'm not going to multiply pi or 3.14. Then moving into my H, how far apart are my two circles? I'm going to use that 12. And now I can find my volume, which would be that 16 pi times 12. And when I multiply that 16 times 12, I'm going to get 192. Just make sure we include that pi back in there with our centimeters cubed. All right, let's move into number 3. So as I might have mentioned earlier, when you have all of your sides as rectangles, you can go ahead and decide which one you want to be your base, and just make sure you're using the side parallel and congruent to it as the other base. So these two here are what I'm going to use as my capital B that I'll find the area of. So since it is a rectangle, for area of a rectangle, we have our base times our height. So 15 times 6 is going to give me 90. And then my H is going to be that 10 from base to base. So to find the volume, I'm going to just multiply that 90 times 10 to get 900, and we're going to use units cubed since there are no units provided. Now for my classes, they don't get a formula chart where I give them out every single formula. They get very basic ones of just the volume of a prism is going to be capital B, area of the base, times the height. But if you are wanting to use another formula for a rectangular prism, it would also be that length times width times height. So that's a shortcut with it too. All right, now let's look at number 4. So in number 4 here, I'm going to identify my base as these two right triangles. I know that because over here on the one I'm currently highlighting, I'll see that right angle. Okay, so since this is a right triangle, we are going to have that our capital B formula, we're going to have that 1/2 base times height. We need to use our two lengths that are perpendicular. So that's going to be our 5. And then this side over here that I currently know nothing about. So I'm going to use Pythagorean theorem once again. My 5 squared plus b squared is equal to 13 squared. I'll get 25 plus b squared equals to 169. And therefore my b is going to be equal to the square root of 144, which just gives me 12. So plugging in, I'm going to have that 1/2 my base. I can use the 12 times my height of 5. So half of 12 is going to give me 6, and 6 times 5 gives me 30. Okay, my H here is just how far apart are those two right triangles, and that's going to be the 20. So to find the volume, I'm just going to multiply my 30 and my 20 together to get 600. And since there are no units, once again, we're going to include units cubed. All right, moving into the last one for this front side, we have find the volume of the right prism. Note, all angles are right angles. Okay, so here we can find our capital B and then multiply it by the H, or you can separate this into, so I'm going to draw a little shape here. We can separate this into two rectangular prisms. It's completely up to you. I'm going to go ahead and show you where we are just using it as one. And so I'm going to call this my rectangle 1 and my rectangle 2. So I'm going to find my capital B, my area of the base, by just identifying those two areas. So to start off, I'm going to have my rectangle 1, which is just my base times my height. So here we have that 7 is given to us. And so I would need to know what is the length of this segment here, which I can see the 21 on this side being used. And then them telling me that this whole thing over here is going to be 25. So I'm trying to draw a little squiggly so you can see which lines. So in order to find what I need here, I'm just going to take that 25 minus 21, and that's going to leave me with 4. So the area of that rectangle 1 is just going to be 7 times 4 to give me 28. And then for my rectangle 2, I would have that 21, and then I would use the 30 that I see down here. Okay, so when I multiply those two together, I should get 630. So for my capital B here, I'm going to take that 630 plus the 28, and I can get 658 for my capital B. I then am going to use my H to be that 5. How far apart are they? And so I can find the volume by just multiplying my capital B, my 658, times 5. Which should give you, we get 3,290, and we'll have our units cubed again. All right, so we're going to go ahead and flip it over to the back side. And so for this problem, we have that the volume of a cylinder that has a height of 8 inches is going to be 200 pi inches cubed. And we're going to find the the length of the radius. My bad. All right, so let's start by plugging in everything that we have for our formula. So we have that we're finding the length of our radius, but we are using volume of a cylinder. So that's going to be my capital B times my H. So I'm going to plug in what we know. We know that our volume is 200 pi. And we know that our height is 8. So that capital B we don't know anything of yet, but we know our H can be 8. So what I can do to start this off is I can divide by 8. And when I divide that 200 by 8, I'm going to be left with 25 pi is equal to that B. Now, my B, remember, is area at the base. And since we have a cylinder here, we know that the base is going to be a circle. So that 25 pi is just equal to our pi radius squared. And so I end up getting that my radius is just going to be equal to the square root of 25, which gives me 5 inches for my radius. Okay, moving into number 7. The plane region is revolved completely about the y-axis. So real quick, I'm going to start off by just highlighting my y-axis here. Okay, and I'm going to highlight a little bit more over here so I can see it clearly. And so what I do with this is, because I know I'm going to revolve it around this line, I'm going to draw a mirror image on the other side. And I'm going to then connect them using a circle, since, like I said, we're going to have that circular base since we are revolving completely around this line. Okay, so this is going to have my reflection, and then, like I said, I'm going to connect them with a circular base so I can get an idea of the shape that's being formed. Now, it's not going to be perfect, but it will give you an idea of what is happening. Which you'll start to kind of see a cylinder shape being formed, but with a cylinder-like hole through the middle of it. Okay, so for this, I'm going to go ahead and say, when they say to describe the solid, I'm just going to say what I see. If it was just a regular cylinder, I could just call it a cylinder. But since I have that hole in the middle, I'm going to call it a cylinder with a cylinder cut out. Then they're asking me to find the volume of it in terms of pi. So we can find our capital B, since this is a prism, okay, by taking the circle, the big circle that we have. And in order to find that radius, you do need to start at the line that you are reflecting over and counting. And so when I do that, I'm going to see that I will be having a radius starting from here of 1, 2, 3, 4. So my radius is going to be 4 for that larger circle. But what I'm going to do is I'm going to find the area of this full base, which is a circle minus a smaller circle in it. So I'm going to start with my big circle. By finding its area, which, like I said, is at 4 squared times pi, which will give me 16 pi. Then I'm going to find the area of the small circle, and I'm going to subtract them, and that should give me the area of the base. So my small circle is going to, starting at the line I'm reflecting over, just counting over, I'm going to have a radius of 1. So that's just going to be pi in general, because 1 squared is just 1. So for my capital B, I would take that 16 pi, my big, minus the small, which is pi, to give me 15 pi. And then my h, just figuring out how tall this figure is, we are going to have 1, 2, 3, 4, 5, a height of 5. And so my volume is just going to be that 15 pi times 5, which will give me 75 pi units cubed. Okay, so just mentioning, kind of like on the front side with the last problem, you could separate these and you could do a big cylinder, and then you could do a small cylinder and subtract those two volumes, or if you just find the capital B area of the base as a whole and multiply by the height, that will give you your answer as well without you having to then do the subtraction after. All right, so moving into our last problem, we have here that a cylindrical hole with a diameter of 6 centimeters has been cut out of a prism. Okay, so real quick, I'm just going to draw on here that I have a diameter of 6, which just means that I'm going to have a radius of 3. All right, we're going to find the volume of the remaining solid. Okay, so we're going to start with our capital B, area of the base. We see that this is a rectangle with a cylinder cut out of it, the rectangular prism, with a cylinder cut out. So I'm going to start with the rectangle's area, which is just that base times height, which is going to be 15 times 12. Which that 15 times 12 is just going to give me 180. And then we are going to find the area of the circle that's being cut out of that base, which we said is going to have a radius of 3. So we're going to have pi r squared. So 3 squared is going to give me 9 pi. So therefore, my capital B, my area of the base, is going to be that 180 minus 9 pi. Then moving into my h, my height, I'm going to have that 22. So for my volume here, I'm going to take my capital B, that 180 minus 9 pi, and I'm going to multiply it by my h. Now, since I am multiplying something that could not be simplified into 1, I'm going to make sure that I distribute into both of these that 22. So that 180 times 22 is going to give me 3,960 minus, and then that 22 times 9 should give me 198, and then we'll have that pi with it as well. And we'll have our centimeters cubed for our final answer. Remember, because one of them has a pi and the other one doesn't, this cannot be simplified any further. You would leave it as what you see here, that 3,960 minus 198 pi centimeters cubed.